Hi, my name is Camiel Vanderhoeven, and I am the Chief Architect and Strategist for OpenVMS at VMS Software. With OpenVMS version 9.2.3, we announced support for VMware vMotion. And vMotion is a technique that can be used to move a running virtual machine from one ESXi host to another without downtime. In this video, I want to demonstrate how to set up your VMware ESXi environment to make this possible, and then demonstrate vMotion on a virtual machine running OpenVMS version 9.2.3. So first, I want to show you what I plan to do in this video. Then I will show you how to install ESXi, how to install vSphere, and how to create the VMware cluster. And once that infrastructural foundation is in place, I will install OpenVMS on a new virtual machine, make that VMS instance a member of a cluster, and then demonstrate how to perform the vMotion. So here's the plan. We start with an existing cluster, which consists of a couple of Itanium nodes running OpenVMS 8.4.2L3. I'm going to add an x86 node to that cluster running OpenVMS 9.2.3. That node runs on a VMware ESXi host, which is part of a cluster with another ESXi host. We need some shared storage in the cluster for disk images, and we need vCenter vSphere to manage the cluster. And with that setup, we should be able to move the x86 node from one host to the other. I'm setting all of this up in my home lab, and I'm using some older HPE Blade servers with FlexStand Virtual Connect networking. That way I can have multiple 10 gigabit networks between virtual machines, between hosts. Now, these are not on VMware supported hardware list, which means we will see some warnings that you would not see on supported hardware. So the Itanium nodes run on BL860C i2 and i4 blades, and the ESXi hosts are BL460C Gen 9 blades. So first, let's install VMware ESXi. I'm going to use ILO to boot the blades from the ESXi installation ISO image. Booting takes a while, most of which I will skip. But eventually the ESXi installer comes up. I'm installing ESXi on the internal disk, and I set a password for the root account. There are some warnings about unsupported hardware, and then the installation is actually complete pretty quickly. We reboot, and then we find ESXi running. I'm going to give it a fixed IP address rather than DHCP. So I press F2 and I log in using the root account. This brings me to a menu where I can configure the management network the way I want. I'm going to do this on both hosts. I'm only going to show it once, but I do this twice. So I set IPv4, I set up DNS. And then when everything is done, this ESXi host now fits neatly into my network architecture. Now, I need to connect one of those two ESXi hosts to iSCSI storage before I'm going to install vCenter vSphere, because I want the virtual machine that vSphere runs on to be vMotion capable as well. So I go to the ESXi web interface and I log in using the root password. Here, I'm going to head over to storage. Then I'm going to go to adapters and click software iSCSI. I set it to enabled. And then I'm going to add a port binding to the management network interface. Now, ideally, you would set this up on a separate interface. I'm going to set up a dynamic target and give it the IP address of my iSCSI storage. And after a refresh, we see an iSCSI volume on which I can create a VMFS file system. To do so, I'm going to click New Data Store, give it a name, and then just select the defaults. So if I now go to storage and then to data stores, you can see that I now have both the internal storage as well as the 2 terabyte storage on the iSCSI storage. The next task is to install vSphere to manage the VMware cluster. This is done through a configuration utility that runs on Windows, so I'm going to start that. Going to select Install, accept the license, of course, and then I'm going to provide it with the address of the ESXi host and the root password for it. There are a few checks, and then I can give the vSphere virtual machine a name as well as set a root password for it. You can select from different sizes of deployment, but tiny is more than enough for what we want to do. So I select the data store on the iSCSI for this virtual machine. And then I need to provide the networking details for this vSphere server. So once I've provided all that and click Finish, the installation begins. That takes quite a while, which I'm going to skip, but eventually we have a new virtual machine running on the ESXi host. So there I go back to the installer and I start stage 2 of the installation process. This is the stage where you need to provide some more information, including the username and password you're going to use to log into vSphere later. So once I've put in all that information and click Next and Finish, the second stage of the installer starts. Now this takes a fairly long time, but eventually we'll be able to log into the new vSphere installation through a browser. So let's start doing that and get our ESXi hosts into a cluster. So I log into vSphere. And then I'm going to go to Actions and create a new data center. When that's done, I'm going to select the data center and create a new cluster. Now we want all of our hosts in the cluster eventually to have the same image. So we're going to import an image from a new host. And that new host is the ESXi instance that we're running the vCenter server on. So once I click Finish, creating the server takes a little while, but eventually it's done. So if I go to the right tab here, I can select the cluster. And under Actions, I can choose to add a new host to the cluster. So I give it the IP address and root password for the second ESXi server host. So when I click Finished, the second host gets added into the cluster. So we now have a 2-node cluster. However, this second host doesn't have access to the iSCSI storage yet. So from the vSphere interface, I'm going to go through the same steps to enable iSCSI and connect it to the iSCSI storage. So I'm going to add an iSCSI adapter. And then I'm going to give it the IP address of my iSCSI server as a target for dynamic discovery. So now that we have done this, we can access the iSCSI VMS data store from both ESXi hosts. So the next thing I'm going to work on is networking. I want to create a distributed switch across these two hosts. So I go to Actions, Distributed Switch, New Distributed Switch, and then I select all the defaults. Next, I'm going to select the newly created D-switch, and I'm going to go to Actions, Add and Manage Hosts, Add Hosts, and I'm going to add both of the ESXi hosts to the D-switch. And on each host, I'm going to add 2 NICs, and these are configured in Virtual Connect to connect to the outside world. I'm also assigning the virtual machine networking for the existing virtual machines to that new distributed switch. So once those actions are complete, I can see that the dport group contains both ESXi hosts as well as the vCenter virtual machine. And using this D-switch, a virtual machine can maintain its network connection when being vMotioned between hosts. For the vMotion, we need a separate network connection, and that's recommended to be a dedicated 10 gigabit or faster network connection. So I'm going to go to Action, I need to do this on each host separately. So again, I'm going to go to Actions and Add Networking. I'm going to add a VM kernel network adapter using a new standard switch. And I'm going to assign 2 adapters, one as an active adapter and one as a standby adapter. These are configured as a separate network in Virtual Connect, no connection to the outside world. I'm going to label it vMotion, and rather than the default stack, I'm going to pick the vMotion TCP/IP stack, which is optimized for vMotion traffic. I'm going to give it a static IP address in a separate subnet. Remember, this is a completely separate network. And then hit Finish. And of course, I'm doing the exact same thing on the second node. So if you now look at the virtual switches, you can see the D switch that is used for network connectivity for the virtual machines. You can see vSwitch 0, which is used for the management network as well as for iSCSI, and you can see vSwitch 1, which is used for vMotion. So I can now demonstrate how vMotion works by vMotioning the vCenter server. So I'm going to right-click it, select Migrate, change Compute Resource Only, and I'm going to move it to the ESXi2 host. Going to make it a high priority vMotion, and when I click Finish, we go to the summary for this virtual machine. You can see the IP address on which it runs on the right-hand side of the screen change from ESXi1 to ESXi2. So this demonstrates that vMotion works on this ESXi cluster the way we've now set it up. So on to installing OpenVMS. I'm going to create a new virtual machine. So I'm going to go to Actions, New Virtual Machine, create a new virtual machine, and I'm going to give it a name. I'm going to install it on ESXi1, and then later we'll move to ESXi2. Make sure the storage is on the iSCSI. Compatibility is ESXi7 and later. And for the guest OS, I'm going to select other 64-bit. I'm going to give it 4 CPUs and 8 gigabytes of memory. I'm going to add a SATA controller, and I'm going to give it a 40 gigabyte hard disk, which lives on the iSCSI storage, connected to that SATA controller. I'm going to remove the SCSI controller, which we do not need. And for the network interface, I'm going to make sure that it's connected to the dport group rather than due to the default VM network. I'm also going to change the IP address to match the DECnet address, which I'm going to set up when I install OpenVMS. So the DVD drive, I'm going to connect to an ISO image of our installation kit, which I've stored previously on the iSCSI storage. And I'm going to make sure it's connected at power on and connected to the SATA controller. And then under VM options, I'm going to make sure that we use the EFI firmware rather than BIOS firmware. And under advanced parameters, I'm going to set EFI Quick Boot to false. And with that, I can hit Finish and our new virtual machine gets created. So I'm going to power it on and launch the console. So here we see our boot manager, and the first command I'm typing is OPA0 to enable the guest console. And then I'm going to boot from DKA100, which is our emulated DVD drive. Now, I'm not going to guide you through the whole installation of OpenVMS because that is fairly well documented in various other documents as well as videos, which you can find through our website. So I'm going to refer you to that rather than show you the whole installation process. I do want to show you the guest console though, so if you bear with me while this image loads, when it gets to 100%, the installation kit will boot, and then it will switch over to the guest console. So while we're looking at this, OpenVMS is booting in the background without much output to show for it. And eventually it will bring up the installation menu. So here we pick option 1 to install OpenVMS, and we go through the normal OpenVMS installation. If you're unfamiliar with that, we have an installation guide for version 9.2.3 that details the whole process. After the installation and the necessary reboots, I'm also configuring TCP/IP, I'm configuring DECnet, and I'm making this OpenVMS node a member of the cluster with the Itanium nodes. So I'm going to run cluster config for that. I'm going to end this part of the video here so that I can demonstrate the vMotion rather than bore you with the whole installation of VMS on the screen. So to perform the vMotion, on the left I have the guest console. On the right top-hand side, I have a view of the cluster being refreshed every second from one of the Itanium nodes. And in the right-hand corner, I have an SSH session into the x86 node running monitor CPU with an interval of 1 second. So in the guest console, I'm going to log in as systest, and I'm going to run UETP. I'm asking UETP to set up a load test with 40 simulated user loads. And when that starts in the right-hand corner of the screen, as you can see, the CPU gets pretty busy. So now this virtual machine running x86 is using all 4 of its CPUs continuously. And I'm going to migrate it. So migrate, move it to ESXi 2. Click next a few times. And then I'm going to scroll down to where we can see the IP address of the host that this virtual machine is running on. And as you can see, the vMotion has already happened in the time it took me to scroll down because it's running at the IP address of ESXi 2 already. And in the log, you can see that the relocation succeeded. So let's do that again so that you can see the IP address of the host that we are running on changes. So now I'm going to move it back to ESXi 1. And if you watch the IP address next to my mouse pointer, you can see that it changed from ESXi 2 to ESXi 1 again. So I'm going to do that again, move it from ESXi 1 to ESXi 2, but now I want you to watch the 2 screens on the right of this video so that you can see that the cluster stays up and that there's nothing untoward happening in either of those 2 displays. So now is the moment when the vMotion happened, and if everything went the way I thought it went, you did not see anything happen in either of those 2 screens that you wouldn't expect. So this is how we can perform a vMotion of a running x86 VMS system, even in a cluster, without any user noticeability of the fact that that vMotion happened. The cluster stays up, the application stays up, and everything is fine. So I'm pretty happy that this works the way it does. And I'm hoping that you've enjoyed this video. I want to thank you for watching it. There are plenty of other resources on our website available for you, so I would advise you to check that out. And if there's any other OpenVMS related topic that you would like us to do a video on, let us know and we will see what we can do. Thank you, and thank you for your attention.